Hi everyone. My name is Gerard Maulino. I'm a solution architect for castLabs. castLabs is a company providing services in the cloud for multiple DRM and video transcoding and packaging. We are also providing some player SDK for all kind of platform, iOS, Android, and web. And I'm going to talk to you about low latency and also ultra low latency, because those things have changed recently in the OTT market, especially on OTT, so that's what we are going to look at. So usually what we had in OTT since almost last year was about 45 seconds of delay on the live edge. That's an average. It's between 30 or 60 seconds, depending on how you package your content. But that's usually the delay you got when you had to watch live. Compared to broadcast latency, which is about 5 seconds, depending also on if you are using modulation via satellite or terrestrial, it could add a little more, but it's usually around 5 seconds. So the OTT live was a bit behind. I mean, it's like what we were watching the past, basically. And for live events, sport, or other kind of event was sometimes annoying. So some group of people had a look at how to solve this problem. And there are many ways to do it. You can go to ultra low latency using some technology, but you can also improve the standard latency. And I'm going to show you how to do that. Let's talk about ultra low latency first, which is, I would say, the extreme way of doing it. And since a couple of months and now a year, we are actually supporting ultra-low latency for OTT, which brings us to show video within 1 second from the origin server to the player. This is in a lab setup, so it's not in a real environment, but I will show you that it's also possible to achieve some very good latency. This technology is available for any kind of platform, so Android, set-top box, browsers, iOS. You can also address TVs if they support MPEG-Dash especially, or HLS. And the main technology that you have to use to go that low is called CMAF. So CMAF is something that is very useful also if you want to get rid of the multiple format that you have, like HLS for iOS and Dash for the other one. With CMAF, you have a common format. But that's not the only interesting stuff in this specification, because in CMAF we have different size of segments, or we have segments with multiple fragments inside. And this is very good for us if we want to go low. That's not the only thing that you have to change. Actually, if you want to go to very ultra-low latency, there are basically 3 pieces that you need to change. You need to update your packager. Even encoder needs to support some profile with very high availability to provide the frame very quickly. But your packaging needs to support CMAF and build very small fragments inside your segment. We have an example of some companies who are doing that. We work with Anivia and Broadpeak and some others who are already supporting this format on live streams. The other thing that you need to support is HTTP 1.1. This one is important because that's how you can get the bytes from one file without requesting the whole file. Because usually when you do OTT, you download your manifest and then you have the list of segments, and you need to wait for the end of the download of the segments before to start the playback. With HTTP 1.1, you can request a piece of that segment, so you are not, you don't have to wait for the full size of the file. But this protocol needs to be supported on the packager, so the origin server, but also in the CDN, because if in the middle you have a CDN server, they also need to support that technology. Akamai is one good example, but there are other CDN vendors who provide this HTTP 1.1 technology. Now on the player side, this is, I would say, where you have the most work to do to reach the live edge. So you have to support CMAF, you have to support HTTP 1.1, but you have to add features also to go to the live edge as close as possible. And that's a good example of what we are doing in castLabs. So let's have a look at how it works, the kind of workflow we are supporting right now. So this is a typical workflow where we have the encoding, packaging, live origin, producing the CMAF chunks. At this stage, we also have a multiple DRM system in our cloud, so we can ingest the key for the encryption of the chunks. And once it goes through the CDN, the player will request the DRM license, and then it starts playback as close as the edge, live edge as possible. Now, let's have a look at the regular low latency quickly. That's basically one segment of data. So you have, let's say, 2 seconds of live stream. You download that chunk, and you are able to play back. But you play back already 2 seconds late. So how we can improve that? With CMAF, we can, again, we are in the same segment, 2 seconds, but we can go lower thanks to the CMAF technology, because this technology can allow you to fragment this piece of content even in little smaller chunks. So for each segment, you can have a small fragment as small as 1 frame. So you can go down, in theory, with a 1 second segment to like 41 milliseconds. Now, so for ultra low latency in real world, let's say when you have the CDN, you have the live packager and encoder, and the player that supports that, you can go as low as 200 milliseconds for a 25 frame per second movie. This is on a lab. This is really on a local setup that we have on our booth, for example. But with production environment, what we have typically observed is that you can go as low as 1.2 seconds for this format, for ultra low latency with CMAF, which is very nice compared to the old 45 seconds that we had before. And we are also much more reliable now because we can control that latency within the player. Now regarding HLS and Dash, there are some things you can configure also to, let's say, change this latency. You can change the chunk size, you can change the fragment size, but basically that's in average what you get for MPEG Dash and HLS when you have 1 or 2 seconds of segments. Which is not bad, actually. 5 seconds for regular latency is quite good. The way to achieve that is mainly on the player side. Okay, so you now have to still produce your main manifest and list some of the segments, but you can circumvent the way you do that. Usually you have to put 3 segments minimum. That's what the specification says. If you put less, you are allowed to download more quickly, and you are allowed to provide next to the live edge live stream. But the player has to jump right to the live edge. How it does that? It can just play the last segment of the playlist. If you have a 1 second segment, so basically you are in theory 1 second late. But of course, with the CDN, you have the nodes, the network nodes in between them have some latency already, so you need to actually wait for that download of segments before you get it and start the playback. Now, that's one thing that is very good, is that you can achieve very fresh live. You can provide live football sports to your users within, let's say, 5 seconds or 2 seconds. But one thing that is annoying is that maybe you already experienced that, is you are watching your favorite soccer game and your neighbor is getting the goal before you. So that is one thing that we can solve with the OTT latency improvement, but we can also solve that in a way that we control the latency. So that's, I would say, the next step, the new challenge in OTT, is to provide the same frame at the exact same moment to all your users to make sure that the experience will be the same. So nobody is screaming because they hear about the goal just before you. You can provide the exact same frame at the same time. How to do that? You basically have to add a bit of buffer to make sure you get enough for the display, but you can also have another system that controls when you will display the frame for every user. Another thing that is also challenging with this ultra-low latency system is especially the adaptive bitrate, because you have multiple layers. And how to switch to multiple layers? Usually the players calculate the download bandwidth when it's downloading a segment, basically. Now we are downloading a very small piece of segment. So you have the metadata, you have a very few amount of data that is useful to the decoder. So it's hard to be very accurate on this computation and estimation of bandwidth. That way you are also expected to not switch to another layer that will basically ruin the experience and block this view. So this is a new challenge for these OTT players. You basically have to find a way to compute your bandwidth, the user bandwidth, without basing your calculation on the segments download. Now let's talk about DRM, because we also have a DRM system. We protect the live streams, so we add the key ingest and the license delivery when you play back. This is not really adding latency to the streams. It's adding a bit of start time, because you need to download that license to be able to decrypt your content. But once it's downloaded, the playback can go right straight to the live edge. That's all I had to say about that. So I hope you like this speech, and I invite to come and visit us to our booth, SU 107012. We have demos with ultra low and low latency with some of the partners we are working on. So thank you.